Namaste students. Now in today's session we will see transportation problem. Now we are in the last chapter, that is 8th chapter, operation research. In that during our last session we have completed with the LPP problems, linear programming problems, and today we will discuss about transportation problem. And linear programming problem we use in the organization for the purpose of how we can utilize the available limited resources in a best possible manner. But in case of transportation problem, what is the use of this transportation problem? This is to how to minimize the transportation cost. Now quantities we transfer from one sources to different destination. While transferring it, how we can minimize the cost of transportation, that we are going to study in transportation problem. So transportation problem is considered as a special type of linear programming problem. It is one special type of linear programming problem whose objective is to determine the quantity of units to be transported from various origins to different destinations at a minimum cost. It is a special type of linear programming problem and whose objective is to determine quantities of units to be transferred from various origins to different destinations. Origins are nothing but we can take it here, the factory, you can take the factory or the warehouses, these are the origin. And different destinations. Different destinations means it might be the we are supplying it to the distributors, or we are supplying it to the wholesalers, or we may supply it to the retailers. So those are our destinations from factory where we need to transfer this particular quantity. And we present this transportation problem in a rectangular form. We present a transportation problem in a rectangular form. How we present in a rectangular form? So there is a origin, or else we can call it as source. Origin or else source, that we O1, O2, then here O3, O4 and OM. We get in OM. Then here we can see destinations, different destinations. Destinations are, we write it D1, then D2, here comes D2, D3, D4, then here at last here comes DM. Now, next comes where, here it is availability. Availability we denote as AI, and here comes requirement. Requirement we denote as BJ, small letter B and J. That is a requirement in different destinations and availability in different factories or origins. What are the availability? We represent availability as AI and requirement as BJ. So here B1, requirement in the first destination. What is the requirement of quantity? In destination 1 or in one particular retail shop, this is the requirement. These many units of some things are required. Now in second retail shop, what is the requirement? B2. These many quantities of goods are required for this particular shop. Then here comes, that is BN, and here comes, that is A1, availability. These many quantities are available in this particular factory. And A2, these many quantities are available in this particular factory. These are the availability. Last one, AM. What should happen at the end? Sigma AI should be equal to sigma Bj. Means availability should be matched. Then we can say particular transportation problem is it is balanced. Now what happens here? Here we can say it as first we need to take row by C, 1 and this one. First row and first column means this is the cost. The cost required from this source means this factory to this particular place. When we transfer, what is the cost associated with it? What cost associated with it? That is, then here 2, 1, here it is 1, 2 and here it is 2, 2. It goes like this. Now see here, this is the cost from when we transfer goods from O1 source to D1 destination. O1 means that is any one of the factory which produce some of the articles or quantities which is required for this particular shop. So we are transferring goods from this factory to this shop. What is the cost associated with it? From this source to this destination, what is the cost associated with it? And now here we allocate. Now what allocation we do means based on here in this factory means what are the requirements. These many quantities are available. These are the availability in this particular factory and what are the requirement in source. We can allocate here based on the what is available in the factory means which one is minimum. If requirement is minimum, then we can allocate their complete requirement. If availability is minimum, we have to allocate what is available there. More than that, we cannot allocate. So that is allocation. We call it as we present in the form of X. From here to here, what they require, but what we allocate for them. This is X 1, 2. Here X 2, 1. And here X 2, 2. See, don't worry, this is just they have given that rectangular form is given in your syllabus. So that purpose I have given here. This is a rough idea. You get one rough idea. Your problem will be present in this form. Then other things you will understand when we solve the problem. Now here we have taken some of the terms. Where m is equal to, we have taken here m, that is number of sources or origin, and m is equal to number of destinations. And what else? AI quantity of goods available, and BJ quantity of goods required. C is equal to cost of transportation. And X is nothing but number of quantities allocated. Number of quantities allocated. Here, transportation problem we present in a rectangular form where we have to transfer goods from different origin or sources to various destinations, and where n is number of destinations. These are the number of destinations. M is number of sources. AI is quantity of goods available. BJ is quantity of goods required. And C is cost of transportation. X is number of allocation, what quantity we allocated. Now there are some basic definitions or some of the basic concept. We'll see that concept now. Then we can go for the problems. Now there are some of the important definitions. They have given us important definition, but we can take it as some of the important concepts. Concept means some of the terms which you should be knowing before going into the problems. So there first thing there we have that concept term called feasible solution. We use the word here. The given solution is a feasible solution. What is a feasible solution, or when we can call a particular solution as a feasible solution? It has to satisfy three conditions. Then we can say it is a feasible solution. So that condition is sigma. First condition, that is sigma xij is equal to ai. Sigma xij is equal to ai. Second one, sigma xij is equal to bj. Then third one, that is xij is greater than 0. So there are three conditions. That is first one, sigma xij is equal to ai. Sigma xij is equal to ai. That means what number or whatever availability or else whatever requirement will be there here. At the end, after getting solution, what we allocated, this total should match this row and also here column wise. Column wise also it should match. Here we allocated for these two. Here we did not get any allocation. Only here. For example, here in the column where 10 is there. Here requirement is 10. In this particular destination, requirement is 10. While allocating, here we allocate 8, here we allocate 2. So yes, it satisfied this 8 plus 2, 10. For example, here only 8. Here availability is 8 in this source. What we allocated here 8. Here we did not allocate anything. So 8. So it should satisfy. For your understanding, I will tell after allocation by getting solution, it should match this row and column. It is not row and column. It is availability and requirement. AI is availability. BJ is nothing but requirement. It should, what allocation we do there, the sum of that allocation, it should match the particular requirement and particular availability and requirement of that particular destination. From that source it should match. That is the first one, first and second one. Then third condition is xij. What is xij? What do we allocate here? What do we allocate? It should be more than 0. It should be more than 0. If it is more than 0, then only we can say that it is a feasible solution. Otherwise, we cannot conclude it as a given solution is a feasible solution. So that is this feasible solution. We can say it is a feasible solution when it satisfies these three conditions. First one, sigma xij, that is this one, it should match ai. That is availability. Second one, what allocation we do, it should match particular requirement. It should match with requirement also. It should match with their availability. That is the first one. Then basic feasible solution. Here it is feasible solution. And what is a basic feasible solution? Here one more rule is there, that is m plus n minus 1. What is that m? M is nothing but the row. Row in the sense m is nothing but different origins or sources, and n is nothing but different destinations. M is source and n is destination. For a better understanding, you can take as this is row and this is column. M is row and n is column you can take. And you have to count how many destinations are there. For example, we take here, we don't know how many, we take 4. 1, 2, 3, 4. 4 destinations are there. Right here D3 and here D4. And go to O3 and O4 will be right. And how many destinations? Destinations are 4. Plus how many rows? Row in the n minus 1. For easy understanding, row plus column minus 1, 1, 2. And what answer we get here, if that is equal to what allocation we do here. We allocate some of the what based on the problem we allocated. Based on requirement and availability, we allocate the quantities. If that quantities, the number of allocation of quantities. For example, here 4 is there, here 2 more will be allocated, here also something, here also something. Then 1 more will be allocated. Now total how many allocation? 1, 2, 3, 4, 5, 6, 7. Now, if this rule, if it matches with the number of allocation, number of non-zero allocations. See here how many allocations? 7 allocations we have done, and that allocation, if it matches with this particular rule, m plus n minus 1. Such kind of problem we call it as basic feasible solution. This you have to use in the problem. Here there is one rule, that is m plus n minus 1. That it is 1 lesser than basic feasible solution is that it is 1 lesser than the number of destination and number of sources. That we call it as basic feasible solution if it matches with the number of allocation what we have done. Then coming to next one, see based on this only we generate two kinds of solution, that is one is degenerate solution and one more is non-degenerate solution. Now what is degenerate solution? Degenerate solution is nothing but, now here we have got that m plus n minus 1 as 7. And we get, for example, number of allocations as 6. Now it doesn't match. Allocations are less. Here only we have allocated 6. 6 we allocated, and here from this rule we have got 7. So here number of allocations are lesser than m plus n minus 1. In such case we conclude the given problem is of degenerate solution. Given problem is of degenerate solution if number of allocation is less than m plus n minus 1. Number of allocation is less than m plus n minus 1. We have to conclude such kind of problem as degenerate solution. Then what is non-degenerate solution? Non-degenerate solution is same condition where number of allocation is equal to m plus n minus 1. If number of allocations is equal to, as I said the previous condition, allocation is also 7. Here also we get 7. Such kind of condition we conclude as it is degenerate, non-degenerate solution. So where number of allocation is equal to m plus n minus 1, such kind of solution we call it as given transportation problem is non-degenerate. Given transportation problem is non-degenerate. If it is less than m plus n minus 1, then we conclude that given transportation problem is degenerate. Now, next one it is optimal solution. What is optimal solution? It is not necessarily the solution should be a basic feasible solution. It can be optimal solution. Optimal solution means when it minimizes the total transportation cost. When it tries to minimize the transportation cost, we call it as optimal solution. So, when it minimizes the transportation cost, we call it as optimal solution. When it minimizes the transportation cost. Now, balanced transportation problem. This is important one more question. The question will be how we can say transportation problem is balanced. Most of the time it appeared in the examination that when we can call transportation problem is balanced. When we can call? When availability is equal to the requirement. When availability is equal to requirement, or else symbolically if you want to write it, sigma ai is equal to sigma bj. Sigma ai is equal to sigma AI is equal to sigma Bj when your availability matches the requirement. But this we will not get to know when the problem is given to us. Here it is not the total. When we solve the problem at the end, if it matches, if both if matches, then we get to know that transportation problem is balanced. Now, which condition is that? When that question comes, you have to write when availability is equal to requirement, or else symbolically you can write when sigma AI is equal to sigma Bj. That means availability and requirement. Then we can call transportation, given transportation problem is balanced. Then last one, transportation cost. You have to find out the total transportation cost. How we can find out total transportation cost? That is, there is a formula called, no, it's not a formula, sigma Cij into Xij. Sigma Cij into sigma Xij. Sigma 2 we have taken here. That means, see, sigma Cij. What is Cij? This one. Sigma Cij, this we have to multiply with the allocation. Then we have to add. So we multiply the cost is the allocation. Then we are adding. That's why we are using two sigmas, and here we need to multiply the cost with the allocation. That total we call it as transportation cost. So this is to find out transportation cost. So these are some of the basic terms which you should be knowing. The feasible solution means which satisfies these three conditions, then we can call it as it's a feasible solution. Basic feasible solution means when it matches with m plus n minus 1. That is requirement and when it one lesser than the number of requirement and number of available. Degenerate solution is when number of non-zero allocations. Number of allocations are lesser than m plus n minus 1. And non-degenerate is when number of allocations are equal to m plus n minus 1. See, these two terms we use in the problem. These two terms we use in the problem and also basic feasible solution. Now, next, optimal solution when it minimizes the transportation cost. Balanced means when your availability is equal to requirement. Then last one, that is transportation cost, where sigma Cij is equal is we have to multiply the number of allocations with the cost. Number of allocations with cost. Now there are some methods. There are two methods which we need to use under this method. In that two methods, according to your syllabus, you are going to study only one method. And under that one method, three techniques are there. And further you are studying only two techniques, not three methods are you are not going to study. So next we'll see which are those three techniques we are going to study. So next we will see the methods of solving transportation problem. There are two steps to solve transportation problem. The first one, finding the initial basic feasible solution. We have seen what is basic feasible solution. So finding the initial basic feasible solution. And second one, what basic feasible we got over here in this step. Optimization of initial basic feasible solution, which we have got in the phase 1. Once the first one it is finding the initial basic feasible solution, and next one optimization of initial basic feasible solution, which we have got in phase 1. But here we are going only with the first step, that is finding the initial basic feasible solution. So there, if we take the first step, finding the initial basic feasible solution, we use there three techniques. We use there three techniques in order to find out initial basic feasible solution. Which are those techniques? First one, methods of northwest corner rule. That we call it as NWCR. In shortly we will write that NWCR, northwest corner rule. We use in the problem also. When you get problem, it will be, they will not elaborate it. They will just write NWCR. That is nothing but northwest corner rule. We are starting from the corner of the matrix. Then second one, least cost or matrix minima method, that is triple M. We denote it by triple M, that is least cost or matrix minima method. We are starting from the least cost or the minimum cost. Now here third one, Ogle's approximation method. But according to your syllabus, we are studying there only two techniques. We are not studying about Ogle's approximation method. Now we have to go through these two techniques, and that is northwest corner rule and matrix minima method. See, these questions also will come for 2 marks. That write the two techniques or write the two methods to obtain basic feasible solution. Which are the two methods? First method is northwest corner rule and second one least cost method. This also may come for 2 marks. And even this question, write the methods of solving transportation problem. Which are the methods? That is finding the initial basic feasible solution and optimization of initial basic feasible solution. This is about methods and techniques which you are going to study in this particular topic. So nextly, today we will wind up with this the theory part, and tomorrow's session or the next session I am going to start with the methods of northwest corner rule, how to obtain the basic feasible solution. For today's session we will wind up. Thank you.